Here you are. Yeah, thank you, Morgan. So I'm the Vice Provost for Global Initiatives and Dean for Earth Resources and Environmental Programs here at Mines. I just wanted to thank all of you for coming. What a fantastic event, and thank you, Morgan and the Payne Institute, for putting this on. I think it's a great opportunity for us at Mines to have this here. I thought it would take just a couple of minutes to talk about how we're thinking about this, the future in oil and gas, and how Mines can respond to that. This is roped into a bigger initiative that we have, Mines at 150, recognizing that we're going to be hitting our 150th anniversary in 2024, and so we have a number of different initiatives going on to advance our mission in the intervening time. And one of those is called the Subsurface Frontiers Initiative, and a big component of that is a new initiative around oil and gas and where that's going in the future. And really with the recognition that much of the growth in production is coming from the unconventional space, that's where we're putting a lot of our effort. Right now we have about 11 different industry-funded consortia on campus that are focused on unconventional oil and gas, and primarily in the shale plays. But I wanted to point out that we have a lot of work going on in other related areas. So that's so here's an anticipated growth curve in the oil production for North America, and then this is other related issues that are associated with that. So we're really trying to think about how we can move beyond just the narrow disciplinary focus that we have been focused on in the past, and integrate other things like water resource issues that are associated with unconventional production, and how the water cycle in that system is important, and we have expertise in that area as well. Issues associated with land use, so this falls more into policy, competition for space with agriculture. All of these things are important, and it's difficult and not wise, I think, to just consider one single component of that. You have to think of it as an integrated system. So we're really trying to figure out how to position ourselves in both curriculum and research to address this from a systems perspective. It's quite important to do that. So with that, I just wanted to welcome everyone here again. Beautiful weather that we ordered up for you, so if you get a chance to enjoy that, you can peek under the curtain and see what it looks like out there anyway. And looking forward to the discussion.
So I've been given the easy task of spending 10 to 15 minutes on talking about scenarios for global energy for the next 30 years, with all energy carriers in all countries taken into account, and all kinds of uncertainties. So I'll try and do that. This is something we do every year. This is Energy Perspectives is our attempt at competing with the likes of IEA and BP and Shell in terms of where we think the world of energy might be going. Next year we'll have a 10-year anniversary, so we'll see what we'll put in then. And it's just to say that it's a piece of independent analytical work. In our case, my boss and the Corporate Executive Committee of Equinor has not read one word in this report until it's published, with the exception of the preface of the CEO. So it's of course colored by the fact that those of us who undertake the analysis work in an energy company that produces a lot of oil and gas and gradually also renewable electricity. But it is truly independent. So this is not Equinor's strategy by any means. When you look at where the world of energy might be going, you have to take into account that there's a massive amount of uncertainty in very many dimensions, and I've illustrated a few of them here. And that's something that can take the energy markets in very different directions, but it's also something that we as energy companies have to think about, and it will adapt. We will have to adapt to it, and it will color the way we behave. Sustainable development is not only about climate change, and in the Paris Agreement we had specific mention of at least three of them, the three to the left, which is climate change, but is also ensuring access to affordable energy for all, and it's eradicating poverty. And then everybody who signed that agreement saw that you cannot solve the climate problem without thinking about eradicating poverty. And of course part of the problem is that if we didn't have to think about eradicating poverty, it would probably be much easier to solve the global warming issue. But you can't eradicate poverty without eradicating energy poverty, and that's one of the problems. So sustainable development in many dimensions is, and most or all of these sustainable development goals are closely associated with energy one way or the other. Just think about how gender equality and increased work participation by women in emerging economies will affect energy demand. Just think through that. And so solving one affects some of the others. We are in a situation where we have definite lack of leadership in this arena, and key leaders in the world are thinking about many different things and legitimate concerns than climate change. That, as long as they do that, and as long as they don't trust each other, is going to make the transition much more difficult to achieve. And being in a situation where we talk more about Brexit, every time a climate policy starts to bite, you get protests like in France or in Ecuador some weeks back. We now even have climate protests in Norway, with single-issue toll road party made a fantastic election result in the local election. So that in a polarized world, it's very difficult to put in place climate policies that actually work as well. And then we have all the issues about digitalization. What that would do to efficiency? Will we continue to use more energy as we digitalize, or will we do less, etc., etc.? What will happen to our workforces? The competence development is also an issue. This goes in and out, I think, for some reason. So there's a lot of uncertainties.
Let's go handheld. Here's a mic there.
Okay. So we've made three scenarios, very different scenarios, building on different assumptions about where different drivers might take us, depending on how you assign weight to things like economic growth, energy efficiency, technology development, climate policies, energy policies. You can produce very different scenarios about the world going forward. And one of them, central case, is called reform. It's based on mainly a market and technology drive. We assume there that energy and climate policies will continue to be tightened, that all the nationally determined contributions in the Paris Agreement will be fulfilled by 2030, and then subsequently tightened. That's not a given, by the way. We think the world there is driven by a relatively benign geopolitical environment where we compete, but we cooperate, and it's a benign competition. It's examples like you don't have a lot of sanctions there, you have a relatively free flow of technology development, you have a comparative advantage determining who produces what, and then we trade on it, which is not the case at the moment, right? That scenario is definitely not business as usual, much more energy efficiency, but it doesn't deliver on climate targets. CO2 emissions peak around 2035, then 2040, and then come slightly down. We're not even close in terms of climate targets achievement. Then we have a rivalry scenario. I think we're the only one that has a rivalry scenario, at least among the big producers of scenario forecasts, where we explicitly take into account the assumption or the possibility that the current geopolitical climate resembles something that could go on for several decades, where we do not necessarily trust everybody, where we do not trade with people we don't trust, where we put sanctions in place, where as a consequence economic growth slows and technology development slows, and where we focus more on security of supply than on efficient solutions. That leads to higher use of coal in countries where you have a lot of coal instead of gas, as an example, but it also increases a lot of renewables in some countries where that is possible, because renewables has the characteristic that it's also an indigenous resource that you don't have or you cannot import. But it's a scenario that has very patchy climate policies and no global drive for addressing climate change. It's not a scenario that anybody should wish, but it's actually, if we're honest about it, this is the path we've been on since the Paris Agreement was signed. And then we have a renewal, which is not a forecast scenario, that's a backcast. We call it renewal. We could have called it revolution. This is a scenario where we ask the question, what does it take to ensure a development in end-related CO2 emissions consistent with well below 2-degree warming, 1.7, 1.8 degrees. And then we calculate our way back. And that way back is not a walk in the park. It's an enormous challenge. And it requires immediate and coordinated policy change, very rapid changes. And that only takes place, we think, in a very benign geopolitical environment where everybody agrees that this is a key global collective challenge that only can be addressed by collective solutions. And this is a little bit about the challenge in terms of energy transition. What is it that we're facing? Well, we're facing global warming caused by growing CO2 concentrations. But to do something about that, we have to handle some of the other things that's a fact. We have a growing population globally, maybe 2 billion more people. That leads to growing purchasing power, more demand for stuff that requires energy, either when it's produced or when it's used or both. So we get growing demand for energy-dependent goods, services, and activities. We have poverty around the world, massive, and we have energy poverty. We have maybe 1 billion people, close to 1 billion people that do not have access to electricity. If we're to address that, we have to deliver energy. And as a consequence, we have a growing energy asset base, much more systems, much more capital that uses or delivers energy. And they have long asset lives. How many people in the audience here have a car that is older than 10 years? Exactly. In addition to 3 or 4 other cars, of course. But a coal-fired power plant being put into operation now will continue to produce electricity beyond 2060. The Boeing 737 MAX, when they figure out how to fly those planes without crashing them, will continue to fly beyond 2060. Probably changing the engine 3 or 4 times, but the fuselage would still be operational like the 747s are still. So making the world more energy efficient while having that growing, very long-lived energy asset base is an enormous challenge. 80% of energy is still fossil. It was 88% in 1973. Some of us remember that. That was OPEC 1. Oil prices quadrupled. It was banned to drive your car in Norway during the Sundays of January, February 1974. Could not drive because oil was such a scarce product. Since then, we've been through massive numbers of revolutions and changes. And the renewable revolution is coming. But 80% of is still fossil fuels. So we have to get out of some of those fossil fuels. And we have to avoid then that all that growth in energy demand leads to another energy addition, which we historically always have had. We add on a new source of energy on top of all the ones we still use. We use wood still, we use coal, we use gas, we use oil, and now we use renewables. Now we have to go through a true energy transition. And that's what the renewal scenario here gives, but not the other two. And since we are in a situation where we do not have lack of coherent global leadership and cooperation, almost in any dimension, addressing any of the sustainable development goals, this task is an enormous challenge. Because we don't have a lot of time, if you're to believe climate change or climate science, before we have to face global warming at 2.5 to 3 degrees. This is the solution. This is the renewal scenario. And the main conclusion is that there's no silver bullet. When we talk about the need to change, we often end up in discussions of, could this solve it? What about this? What about this neat type of technology that somebody figured out on a kitchen bench in Italy? It's called cold fusion. Could that solve it? The point is that we need everything we can think of and more across the board. In our renewal scenario, as an example, we have to triple the rate of energy efficiency delivered energy efficiency. Tripling the rate compared to what we've done over the last 25 years. And IEA was just out yesterday, I guess, with a report showing that the development is going in the wrong direction. Energy efficiency improvements are slowing down. Rapid change in carbon pricing and fuel efficiency standards across the board. Massive subsidized investments in renewable electricity. Radical growth in electrification of transport, depending on batteries. Which means massive growth in the need of batteries, maybe a 20-fold increase in the use of batteries by 2030 alone. And then you can continue. We have 90% of the global car fleet being electric in 2040. That means that more than half of global car sales will have to be electric in 2030 in this scenario. Coal demand has to go down by 80%. Who uses more than half of global coal? China. And India uses 1/3 of the rest. Economies that grow by, in the Chinese case, probably by 4% per year to 2050. And they have to reduce their coal demand by 80% they as well. India will be 7 times larger as an economy by 2050, and they will have to reduce their CO2 emissions in our scenario by 30%. And they have to provide electricity to 600 million people more than what they have today. Some growth in biofuels. We need solid growth in nuclear, by the way. Otherwise, we need much more renewables. 80% more nuclear in 2050 than today in this scenario. And that's taking into account that we're going to decommission a lot of nuclear capacity in the West. we need to put in place in our scenario, which is much less aggressive, by the way, than the Shell Sky scenario as an example, but we need to put into operation 1 million tons of CO2 storage capacity, capture, transport, and storage, 1 million tons every week to get to 1.5 billion tons by 2050. And the rate of speed there, the speed there is not even close to that. And we need to finance the transition, because probably most of the transition has to take place in not only here, but also in the growing energy demand parts of the world, in the emerging economies. They will have to figure out, and they will figure out how to solve this, but we probably have to pay for part of that. And the financing mechanism in the Paris Agreement is not good enough. So we need cooperation. This is what the world then looks like in 2050 across those three scenarios. I'll not go into detail, but since the focus here was on the future of oil, look down here. This is a terrible forecast from a chief economist of an energy company. When my boss saw that, and I said, you know, oil demand in this 2-degree world, renewal, goes down to 50 million barrels, 52. But it could go to 120 if you think about the bribery case. My boss then said that he was reminded of the time when Harry S. Truman became president of the United States, and he asked for a one-armed chief economic advisor because he was so tired listening to economists saying on one hand and on the other. But that's what it is, right? But even in a well below 2-degree world, we're still going to demand almost as much oil as we did in 1970, in 2050. 50 million barrels. And when you look at decline rates, it means massive investments in new oil supply, coming from resources that are there, and most of it has been found. And we don't want too much oil sands or heavy oil from Venezuela in that mix either in such a scenario. So we need light, tight oil and beautiful, sweet Norwegian crude as well, even in that scenario. So then towards the end, to compare, this is how our scenarios compare on 3 variables compared to many other scenarios out there. So this is the terrible forecast, the oil demand. This is the Shell Sky scenario, by the way. Here we compare to EIA, IEA, BP, ExxonMobil, and some of the, I think it's only the Shell Sky scenario, not the other ones. And we've dared to make scenarios that are so different that they span out generally very well what's out there, we think. On gas, we might be a bit conservative compared to other scenarios in terms of demand. This is the Shell Sky scenario. We agree that the global gas demand will be 20% lower in 2050 than today. And then this is the share of electricity which is generated by wind turbines and solar panels. And it goes rapidly, in our case, up to 50% of global electricity. We produce twice as much electricity than as today. So the total electricity generation from wind turbines and solar panels in that scenario is as much as all electricity generation today. So the world of energy can look very different, and if we want a sustainable development, it's an enormous challenge. It's possible, but things have to change, and they have to change very rapidly, and we have to keep in mind multiple sustainable development goals at once in order to make it happen. And whether we succeed or not is not determined in Baltimore or Berlin or Brussels, but in Beijing and Bangalore. Thank you.
I'm not going to say the whole story. I'm just going to add to Eric's story because the context was set by Eric, and this very wide-ranging outlooks of the world energy consumption is, I think, more or less out there. So let me home into our Sky scenario. And Eric started actually off that he made exploratory scenarios, and he was one backcast, basically. We call it normative, right? Basically what you ought to have done 10 years ago. The Sky scenario is also a normative scenario, but not a backcast. So we still have the principles. We start from today. We have the asset base of today. There's momentum in that asset base. The FIDs are taken, and it'll take a while before actually new decisions will change the system over time. So, although this scenario is normative, all right, we still think it's technically doable. There's a big model behind it, right, to test it all, and we think it's economically affordable. And that is something completely different than the lowest cost, which is a political problem to start off with, right? It's an affordable scenario, and people have to really sign up to that. The other thing I'd like to say is that this is one of the scenarios we use for our strategic plan. It's become a more and more important scenario because our shareholders, especially the ESG concerned shareholders, they very much want to know, right, what are we going to do with the energy transition? Are we part of the problem or part of the solution? And they worry about all kinds of things. So this scenario is then, in that sense, also very important there. And it is actually part of the resilience testing of our own Aspire portfolio. So our company has embraced the energy transition for more than a decade, even maybe slightly longer, and it wants to thrive in that energy system. But how do you thrive when all this uncertainty goes on? Because you can be too early, you can be too late. Actually, my company has a few examples being too early. We started the hydrogen system 20 years too early. We were 20 years too early with CCS, so we only have one plant, the Quest plant in British Columbia. So it's all very well to have this vision, the scenarios, and you can get a couple of billion from your CEO to do something, but then actually there's a societal momentum which doesn't give you that license to operate. And that societal license to operate becomes more and more important while we go forward. And that's not straightforward. Well, right, this is our American lawyers who say we don't know the future either. Just to reassure you that everything I say is basically coming from my imagination, I guess. Let's just have a look at the CO2 projections of this world in our scenario. Right, so basically it needs to peak by about before 2030. So actually that's 10 years from now. And actually, how actually can we do that? And here this, let me see this. But anyway, this is the developed world, North America, Europe, and Asia Pacific developed, and you see that actually we're already decarbonizing. It's a normal economic process, of more efficient stuff, right, doing things differently with renewables, and that's well on its way. And that's 1.25 billion people in this world, having about 45% of GDP. And then you have this 5.8 billion coming afterwards, which is the non-OECD, soon to be 7.8 billion, who would like our lifestyle. Now, I don't know if anyone has any clue what it means, but North Americans use about 300 gigajoules per capita per year. Europeans, I think with a similar good lifestyle, used half. We project China to do, again, with half of that of Europe, 70. And actually we think that the emerging economies are going to do leapfrogging as well and going for the best technology. Now, how likely is that, you could argue? Well, that is just taking the waste out of the system. So all the stuff we just heat out of the chimney, if you just get rid of that, right, you could go to something like 70 gigajoules on average. But we made it in our scenario 100 gigajoules, primary energy. So it's easy, 10 billion people times 100 is 1,000 exajoules. So then that's the way it is, round numbers. But I just like to, coming back here, China, the red. This is what you do when you outsource your manufacturing base. Within 10 years, almost a tripling of CO2 emissions globally because it was actually done by coal-fired power stations. So although we have a good feeling that, we reduced our CO2, actually we outsourced our CO2 by China becoming the manufacturing base of this world. And here's a kind of a geopolitical factor, right? If you want to bring investments to another country, that's great for their development, but you're not in control of the CO2 emissions. Then the orange is India. And they're both about 1.3 billion people, roughly. But you see, they're going to leapfrog. They're not, in this scenario, going to make the same mistakes as China is doing with one coal-fired power station. They have to leapfrog there in renewables and other stuff. And then other Asia coming in. This is Africa, by the way, the dark green. That's enormous amount of population as well. And look how little CO2 emissions is projected at. And that is just simply because they're so poor on average. Right? So when you just have, say, a couple $1,000s a year, average GDP per capita, you don't use much energy. But could we be wrong in there? With distributed solar, distributed wind, etc., could they actually develop faster and actually leapfrog there in industrial development, and actually they will put extra strain in the system? We don't know, but that gives you the dynamics of the CO2 emissions. So it's all very well, especially for the Europeans, when we say we have to reduce CO2 emissions globally, but what we really say is, please, others do that for us, right? I mean, and by the way, we don't want to pay for it, of course. That's very consistent with America as well. There. Anyway, so this scenario thinks best practice, and actually it's a normal technological churn. We're not going to decommission plant earlier than its normal economic lifetime, peaking by 2030, and then actually net zero emissions by 2070. Now, net zero means that there's still emissions, and I'll come to that later when at the end of the talk where they're coming from. But you need offsets, basically to compensate for what we call the heavy-duty transport, aviation, trucking, shipping, which is very difficult to capture. Anyway, 50% reduction in 2050. Now, this scenario was made in 2017, published early 2018, and then, you know, it was world was a well below 2 degree scenario, yes, tick, and if we could, a 1.5 degree scenario. And then, end of 2018, IPCC 1.5 report comes out that says, by the way, the new goal is 1.5 degrees. And actually this scenario with a lot of nature-based solutions, so basically reforestation the size of Brazil worldwide, would also become a 1.5 degrees scenario. So in that sense, we think that scenario is still reasonably robust as a kind of a projection, at least for the next 5 years. Still, of course, we see CO2 emissions going faster than it is. Right, let me go for a few key messages from this scenario. First of all, if you want a highly efficient and a low carbon system, you need to electrify that system. And that's actually the blue here on the bottom, and I'll come to that. But here is that invisible fuel, the efficiency gains. Eric already says a factor 3 has to accelerate, and actually the IEA report yesterday on energy efficiency is actually slowing down globally on efficiency. So we're going the wrong way there. But this is stuff, 40% of the solution is energy we're not going to consume. In our scenario, that means that North Americans are going to halve their energy consumption per capita by maintaining your lifestyle and your economic growth by 2050. Just think about that. It's an enormous capital investment game. Right. Then the next thing is actually if you want to electrify your sectoral demand, because this is actually our end consumers. So this is the energies you use as an end consumer, so you lose electrons and molecules. Now these electrons at the moment is only 20% of our energy use. 80% is fossil. So how much actually electricity can you then push in these sectors called buildings, industry and transport? And I think, you know, we average probably buildings close to 95%, industry probably 40-50% if you really do well, but there's always cement, steel, which is going to continue using anthracite coal and other high heat value solutions. And then of course transportation. Bloomberg's very much out and a fantastic projection, all electric vehicles, etc. But that's 25% of all transport. If you take aviation, trucking and shipping with it, then we think in the best case we probably can go something like 40%, 50% there in decarbonization. So the whole world will be struggling to put about just over half its guns, by the way, either renewable electrons or biomass electrons with carbon capture and storage attached to that, to take CO2 out of the atmosphere and actually repair and overshoot where we're in now. So that is, okay, good, we need to electrify. And what does that mean? Well, first of all, you see there's an accelerated growth in energy, in electricity consumption. And that means us. Our homes have to be different, our cars have to be different, the industry has to change at a rate 3 times faster than they used to do. And that all has to go within the next 2.5 decades. And of course, to market design, that means you have to build a supply first before demand can follow. Demand, if you have demand pool, it gets too expensive, and then consumers won't have that. Bit of a political problem to actually finance that and get it go through in the system. Beside the land use, of course, the footprint of renewables is an order of magnitude bigger than the fossil fuel industry or nuclear. And that certainly becomes an issue, even in a country like the Netherlands, where I come from, where we historically know a lot about windmills, but we have already enough windmills and we just started the journey. Right? It has to become probably about 20 times bigger than we got today. And already now society says, well, excuse me, this is getting a bit a lot in my back garden. Right, then so the rest is still molecules. And here the red and the pink is what we call liquid hydrocarbon fuels, which is basically crude oil and biofuels. And I said, but Eric's picture here, you saw this kind of oil demand decline. Yes, but that's not liquid hydrocarbon fuels decline, because actually it hardly declines over this period to the end of the century. The same with natural gas, being replaced by hydrogen gas and biogas. So when you look actually to our present molecular-based energy system, and from an IEC's perspective, well, this is not the end of the world, is it? I mean, okay, our own market doesn't grow anymore, but there hardly any shrinks. It is, okay, our feedstock is going to be from fossil to renewables, yep. We got, 50 years time doing that, yep. Our capital churn is about, 15, 20 years in our company, then you actually replace all your assets. Well, that seems to be doable. If you believe you're an innovative company with enough deep pockets with a balance sheet, etc., that should be doable. Then, of course, is the point is, don't you want to play in this exciting new market of 50% or plus electrons? But I think people start realizing that the profit margin here is not the same as there. Because here you're basically pretty much locked into regional systems, local systems, regulators who doesn't like you have excess profits, and they get caps like we get in the UK, and then I will bleed for a year till so many small companies go bust, and they raise the cap again. So actually, this is a real big energy playing field, right? If people think this, renewables like homegrown and small scale, that's not going to be. This will be for the big boys, big girls, and big tech, maybe I should say. There will be new incumbents there to actually play in that space. But nevertheless, from an IEC perspective, this is quite an exciting world where there's a lot of opportunity, the cards are reshuffled, and obviously we have the confidence that we have a good chance to win in that one. Just people worry about the existing industry. Maybe that's also actually a career advice one. There's still a good career in fossil industry as well while we do the energy transition. So don't forget that. Right, just to round off, back to these CO2 emissions. Where is it going to be happening? And just to do that, basically it's about 50-50. 50% is in the fuel providers, and blue is electricity, and red is the refining industry. And these are the sectoral industry, transport, and then this is buildings. And you see the relative contributions basically today. And actually, where is the reduction going to be? No surprise, of course, in electricity. When you reduce that by renewables, or when you have biomass power stations with CCS. And I'm not going to detail that, but to make a 2 degrees world, you really have to take CO2 out of the atmosphere. And the way we do this in this scenario is via the biomass route. A lot of people think, we advocate CCS because it will prolong the hydrocarbon age, wouldn't it? Yes, but it's the biomass, the bio-hydrocarbon age, not the fossil hydrocarbon age. So, like it or not, you need CCS, at least in this scenario, to reach your goals of Paris. Then actually here you see also a lot of, say, the refining industry and gas industry doing a lot of sequestration, and also, say, when they make biogas or biofuels, they can put that on the ground. Now, the industrial sector is coming down, but very, very slowly. Really more in the end of this period around 2015. That's because of the longevity of the assets. And our steel mills, how much is that? 40 years and other things. Can take a long time. The light blue is the per passenger transport, and here 100% by 2030, within 10 years, I cannot buy anything else than electric car. Sorry, no choice. Forget about it, and your gas guzzlers have to stay in the garage, and maybe a certain circuit you're allowed to play around with that. But just think about it, 2050, the whole world will have to have electric vehicles. That includes Africa, South America, Siberia, Alaska. Just think about what that challenge is, but that's the assumption. So yes, Eric already said we were much more aggressive than anyone else in, say, in electric vehicle uptake, or in solar PV uptake, or in wind uptake, but that's what's required. But then still, the purple is the heavy-duty transport, very difficult at the moment to decarbonize. We have a hydrogen pathway for that, but that is not really starting off till 2050 for reasons I'm happy to answer later. And buildings, of course, can be decarbonized to a great extent. but that will be costly. I mean, in the Netherlands it costs about 50,000 euros, or say $55,000 per house to do that, and people say, sorry, you know, that's a bit a lot of money to spend. Anyway, all to say is that our company is very much also in that decarbonization route. We really want to make traction via the sectoral approach. So we say there's certain global sectors like aviation, trucking and shipping, where there's only actually a few key incumbents, where if we get critical mass with them, right, we can actually make a start to actually in the right direction. So our company doesn't want to wait anymore for this infamous legislation and this infamous coalition of the willing of governments, right, to give us the framework and safeguards our rent models, etc. We just think it's time that industry is going to take the lead. And that is basically a very ambitious goal, but we did some workshops on that, and actually I was surprised to see how much CEOs of large companies, not only in the OECD, also in the developing world, are very keen to start taking part in that process. And well, here you see that you know, the relative contributions. Again, renewable power, biofuels, different modes of transport is very important, but also think about natural sinks. And just to give you an example, like in the EU has a very stringent target, net zero emissions by 2050. Bang. Now, which country can do that? Maybe the Netherlands, 55, if they really push it hard. Denmark, of course, Norway, but Norway's not in the EU, by the way, just for the correctness. But countries like Poland and Czechia, with all the coal-fired power stations, they have no hope unless you start adding their biosphere restoration. That's really what it is, these nature-based solutions. If you put that in, they can bring also their goal net zero to 2050. So it is really part of the solution, but it's not a replacement of all the other solutions. But you see still CCS is relatively modest, but that's still required as well. Anyway, we have a company of quite ambitious goals, but I'll skip that. And as this is an academic institute, people like data. All this data is on our website. You can download the whole data set. You can play with it yourself and see actually, you know, what different parts of the world needs to do, because we recognize that the world doesn't go in one speed. There's a multiple speed. You have leading economies, following economies, and then actually called lagging economies because they're basically not in the economic position to do so. And that's all nicely presented nowadays, and you can download it and play around. Okay, well that was it. That's my presentation. I hope it's just a nice setup for the next.
It's a pleasure to be back at the School of Mines. This is the second time I've been here. It's probably been about a decade since I was here with a delegation from Kazakhstan. And so I'm excited to sort of complement my two previous presenters and talk a little bit about where we are right now. For just a couple minutes in terms of one of the key publications that we do, which is the statistical review, and then sort of put a little bit of precision on some of the points that my two co-presenters highlighted, because I think at the end of the day, you don't need to hear yet another energy outlook. I think it's going to be helpful for us to get into a discussion later on and compare and contrast how we've gotten to the results that we've gotten to. So, okay, can you see that? Okay.
There's a full screen there. The button.
Full screen here?
That one, try that. Yeah.
Okay.
And oh no.
And do hold the microphone closer.
Okay.
Please.
So, number one, we're not on a sustainable path. Last year we saw some of the strongest growth in energy emissions and energy and emissions that we've seen in several years. So you can see both of them moved in lockstep with one another. Also, here in the United States, as many of you know, we saw very, very strong growth in the United States for oil and in natural gas. Both happened in the same year and in the same country. Obviously, that's had an impact in terms of the role that we play, broadly speaking, in terms of exports. We've seen net imports also come down almost to zero, at least in the last couple weeks. And obviously, we've seen some improvement over the last 10 years in terms of the penetration for renewables. And you can see that gas and oil share has continued to increase. Most of that is just increasing amounts of natural gas in the energy mix. And renewables have continued to increase. So here you can see the non-fossil fuel share and renewables reaching about 10%. So the problem, though, is that on a global basis, the fuel mix is basically exactly where it was in 1998. So we're seeing some positive improvements in certain countries, but unfortunately, we're basically exactly where we were over a decade ago. So I wanted to highlight one point in terms of what it might take to keep CO2 emissions flat. And so what this chart is showing is in the blue, increases in energy demand. Light blue is showing improvements in the fuel mix, and you can see that when it's negative, those are improvements in the fuel mix, and when it's positive, the fuel mix is moving in the opposite direction. And so what's happening here in the last several years is, as I mentioned, CO2 emissions is continuing to rise. So we constructed a thought experiment. What would it take if we wanted to keep CO2 emissions flat? And so essentially what that would take, here we're showing that same graph but removing those bars, global CO2 emissions rising up into the above 13 gigatons. In order to keep that flat, we could add the entire amount of renewable generation in China and the United States in 2018. That's roughly 1,000 terawatt hours of renewable generation. And we'd have to add that over the course of the last 3 years just to keep CO2 emissions flat. Or we could engage in a 10% switch from coal to natural gas and achieve the same result. So as my co-presenters were highlighting, this is a solution that is not limited to one fuel. We need all sorts of fuels in order to achieve the decarbonization challenge. So to add a little bit of precision onto this discussion around reducing energy poverty, achieving the sustainable development goals, any kind of solution around decarbonization needs to take both challenges into account, this dual challenge of rising population and reducing the amount of emissions that come as a result. So 80% of the population right now in the world is falling in this mix of consuming less than 100 gigajoules of energy per person. If I could just put a little bit of clarity around some of these dots. So the United States is roughly 287 gigajoules per head. Nigeria, which will become the third most populous country in the world by 2050, uses 7 gigajoules per head. So just think about that. You have a massive amount of population here, even if it doesn't rise at the same kind of rate that we saw in terms of China and India. China, by the way, is at roughly 90, 94, 95 gigajoules per head. Even if it doesn't increase at that amount, it still will require massive amounts of energy going forward. So to try to put this into a picture, here's just sort of how some of our scenarios look. And they look very similar. I'm not going to go into all of the details because it's very similar to the way that my co-presenters have modeled it. So you have some scenarios where that 80% of the population moves down to something like 60% of the population that is still consuming less than 100 gigajoules in some scenarios. And in other scenarios, it's an even lower, a lower portion of the population that is still consuming not a lot of energy. And so that is really the spectrum that you're looking at here. You have a rapid transition scenario, and you have a more energy scenario. And if I could just show you what this looks like in terms of CO2 emissions, here's that more energy scenario. You can see that, is this working? Yeah. So you can see in that red line, it goes higher. In the rapid transition scenario where we have to reduce CO2 emissions by roughly 45%, you can see that it goes far lower. So much of this problem comes down to this picture. How do you provide for more energy while reducing carbon? So I'm not going to go into the individual shares of primary energy that make up this mix. You can see renewables increasing quite dramatically, natural gas staying a very important part of the mix. But the key point I want to make here is that in order to achieve that 45% reduction in CO2 emissions, much of the abatement is coming from power, industry, and buildings. It does not come from transport. So here you can see in this chart that only about 10% of the abatement is actually coming from the transport sector. And so that reflects the fact that it costs less to reduce carbon emissions in power, industry, and buildings, and it costs a lot more to reduce those carbon emissions in the transport sector. And you can see here in each of these, the rapid transition scenario and in the evolving transition scenario, natural gas maintains a pretty large share, and even oil only reduces its share by roughly 4 percentage points versus the evolving transition scenario. So I'm not going to go into some of these charts in terms of transport, but just focus specifically on oil, and maybe this will set the stage for further discussions into the next panel. So this is oil demand in the evolving transition scenario. When you look at what it might look like if we instituted a single-use plastics ban in the OECD and in the non-OECD over the course of 2030 and then 2040 respectively, you basically get a peaking in oil demand sometime between the late 2020s and early 2030s. In a scenario where we banned the use of ICE vehicles, for example, in the sale of ICE vehicles in OECD countries by 2030 and non-OECD countries by 2040, this is what that looks like. And this is not additive, so that's what the ICE ban looks like. And then in the gray, you see the single-use plastics ban. If I added them both together and then instituted other policies in terms of a faster scrappage rate, for example, and also banned the use of oil in power stations, then we get to that rapid transition scenario. And so as my colleagues noted, here you're looking at a scenario where oil demand by 2040 is at roughly 80 million barrels a day. Now, for context, the Sustainable Development Scenario that the IEA published last year shows oil demand going down into the high 70 million barrel a day range by 2040. If I excluded biofuels from that, it's the low 70 million barrel a day range. Now, the issue is that if I take also the IEA Sustainable Development Scenario report and I look at the calculations that they've done in terms of what the decline rate is from fields that do not see incremental investment, and also we don't make investments in new fields, then you're looking at a decline rate somewhere in the range of 4 to 4.5%. So as Eric mentioned, there is still a very large gap here if I am not making any new investments in new fields. Even if I'm wrong on this rapid transition scenario, and that oil demand is down here in the 60 million barrel a day range, there's still going to be needed investment. Now, prices, I don't love this chart, right? It's not ideal because it doesn't actually show the picture of what the world will look like in 2040 or 2050. Prices will ensure that this gap is closed over time. And I think the other important point is to understand that as we look forward into the future, all of these climate models bring with them a great amount of uncertainty. And it's really not clear what oil demand will look like, and what oil demand will look like, and then what prices will look like is obviously going to be a function of the level of competitiveness in the market at any time. So how much cartelization is happening at one point in time determines price, and that is going to create a feedback loop and create more and more uncertainty in terms of what this will mean for oil demand. So I think one of the things that my colleagues will get to in the next panel is looking at the state of affairs in terms of the reduction in cost that we're seeing for oil production. So 25 million barrels a day of new production with a full cycle break even below $50 Brent. But the problem is that the fiscal break even for many oil producers is far above that right now, right? These fiscal break evens are points in time, they're flexible, but it still is important to understand that there's still this wide discrepancy between those fiscal break-evens and the cost of bringing on new oil, which will be an anchor on where prices end up. So there's obviously a lot of different topics that I've sort of suggested here and tried to highlight. I want to conclude with a couple open questions. So as we've shifted from a mode of scarcity to abundance, over the past 35 years or so, for every 1 barrel of oil consumed, 2 have been added to estimates of proved oil reserves, and this goes back to that chart that I just showed before. So based on known oil reserves and using only today's technology, enough oil could be produced to meet the world's entire demand for oil out to 2050, more than twice over. So how prices act in this age of resource abundance really depends on that level of competitiveness in the market, and to what extent can this cartel-like behavior continue to work? That's an open question for the next panel. The other question I have is more on behalf of some of the investors in our 3 companies. How should they be approaching the sector if the pressure has led to the pressure of sale of some of our assets? So for example, we got rid of our Alaska asset in Prudhoe Bay. If the next owner of that asset doesn't maintain the same level of stewardship that we had in terms of environmental concern, is that going to create a problem? How should investors approach the sector? The other thing that I want to highlight is, as Wim highlighted, we have this difference between the amount of new electricity that is going to come into being in terms of the amount of electricity demand, right? And so as electricity demand continues to increase, and as this is looked increasingly as a solution to decarbonize the energy sector, how do oil and gas companies like ourselves compete with utilities that are already in that place? And I think the other interesting question is that if we need to be resilient to all different outcomes in terms of what the world might look like, what is the danger that we might misallocate capital in the future? And when we think about capital, how do we continue to attract that capital from those investors if those investors want a more pure exposure to the energy technologies that are driving this system? I think on that margin, that creates challenges for us. So I will conclude there because I want to make sure that we get to discussion, and thank you again.
Well, thanks very much for having me. It's a great honor. In case you wonder what the Willy Brandt School of Public Policy is, think of us as a little bit of an academic startup, really. Obviously, the aspiration is to get where Mines is. So I guess for the next 150 years, we have quite a job to do. But what I'll try and think about or talk to you about the next couple of minutes is essentially how to think about what we've heard in terms of geopolitics. So the German government had asked a couple of people a while back, a year ago, to do just that. So they asked a couple of people, including Morgan and myself and a bunch of other people, to get the heads around what the energy transition does to geopolitics and what geopolitics might do to the energy transition. And what we came up with is a bunch of scenarios, but those are scenarios that look a lot more into the foreign policy implications of what we have just heard. So let me maybe just walk you quickly through what we came up with. These are 4 scenarios that will build on essentially some of the core drivers that we have learned about from our previous speakers. That's policy, particularly global policy. Whether we have a benign environment or not, these kind of things. National politics, so national choices matter and where countries go with their national energy choices. Technology, there is a couple of assumptions you can make on that. And the way markets react or behave in all of this. What you get in the end is 4 different ways of thinking about the future. Not all of that is necessarily likely, but it's plausible, and that's the most important thing about scenarios. So they inform our thinking. They're not necessarily there because they will happen inevitably. Now, very quickly about those 4 alternative futures that we came up with. The first is what we call the Green Deal. I won't bother you with the details here, and essentially what it is, it's the sky scenario. It's a benign world where you have a strong political consensus globally, led by a bunch of countries, most likely the G20, representing about 80-85% of global GDP, where they go for a strong international policy push to mitigate climate change, to take action. And what that entails is a bunch of measures, including first of all, a very strong signal to financial markets. So they start, it's a policy signal, a credible commitment of the global community. So financial markets start reallocating capital. You get a massive capitalization of low carbon tech firms. They scale up, replace fossil fuel industries and industries that don't change rapidly enough. You have, as part of the deal, a big fund that compensates hydrocarbon producers so that they will avoid a last-ditch effort to flood the world with cheap oil and gas. And you have a very kind of cooperative market environment, so you get a wave of green globalization in the end. All countries share in the benefits, which gets you very low geopolitical friction in the path from high to low carbon. The SDGs that we've learned about before are achieved, and you have something that we would call a just transition for all. Now that's the best of all worlds. And it is a world where essentially all of it comes together. You got the technology, you got the policy push, you got the consensus, you got the cooperation. You have a credible commitment to actually compensate the ones that are not necessarily on the winning end of things. But you can also think about a scenario that is actually a little bit different. Just take out the global consensus and put in technology as the main driver. Technology, for instance, in terms of a massive advance in storage that allows solar, wind, and other renewables to come in very, very quickly. What you get is a scenario where the curves look a little bit different, very, very close to the Green Deal scenario, but still different. A big uptake in renewables. I should have said that green line, and obviously the fossils leaving the system rather rapidly, but not kind of going as quickly or to the extent that they would in the green scenario. Why is this? Well, because the world will look the pathway will look a little different, and quite different actually, if you think about technology as the main driver. So the first question is, where would technology scale up? And the obvious answer is, well, there is a big market. That's the US, a $19 trillion economy and bigger going forward. That's China, $12 trillion economy and bigger going forward. And these are markets that are not only integrated, but also have a very kind of elaborate innovation ecosystem. So that's where you would expect such a technology push. Now, with that, you get new kind of tech giants. We just put Google and State Grid of China in here, but you can take any other. These are just placeholders. The point is, you get new dominant players, and they become part of what people would now call industrial strategy. So less cooperation or a less benign environment when it comes to sharing in technology, more the thinking, more states going to come to, thinking about how to keep technology at home, how to control value chains and supply chains, how to keep the added value mostly where the technology is, and that means you get a world that fractures into camps. Those camps become rivals on things that we've learned about before, rare earth materials and other things that you need to advance technology in low carbon and to keep your technological advantage. It also means that you exclude certain regions, particularly the developing world, that is not among the tech leaders, but also might have problems attracting the capital and the know-how under such circumstances. So in the end, what you get is what we call a clean tech Cold War. That's a bit of an exaggeration probably, but at least you get tensions coming in on a global scale. That scenario is not only bad news for developing countries because of them not necessarily having access to the stuff that you need to decarbonize going forward, particularly in places where you have a lot of population growth, and that's notably in the developing world, but also it is also bad news for oil producers, because this is rapid progress, and those producer states that are dominating at the moment might not be able to adjust in time. Now, a third scenario that we came up with puts domestic politics into the driving seat. And that scenario is one where we call it dirty nationalism, where essentially where populists come to power. In the major democratic countries, including the US, most of Europe, India, and other places that matter just for sheer economic size and population. What you get in the end is a scenario where the dirty stuff stays in and the renewables don't scale up. Why is this? Well, it's for a couple of reasons. First of all, non-cooperative behavior. You have a lot of protectionism going on. Countries focus on what they have. Fossil fuels at home, they try and develop them. Renewables come in as well. We've heard this in the rivalry scenario. It kind of comes close to that probably. But because you have a more fragmented market globally, because you don't have, well, Ricardo cannot do his magic in the end, right? Because you have a lot of protectionism going on. That means the technology cannot scale up to the extent that you would need it. So you have a smaller, a lower learning curve in renewables. And all of that also means that you have rivalries and undermining multilateral institutions, Paris Agreement, UNFCCC, all the rest of it. It just goes away. So what you get is unmitigated climate change with everything that comes with it. The time frame that we've particularly looked at, and that's exactly why it's shaded in here, in all the scenarios is essentially from now through 2030, early 2030s. So by that time, you might already see kind of the results of such a scenario, including conflict over resources and all these kind of things that we have come to debate now even in the UN Security Council. A final scenario is what we call muddling on. It is a business as usual scenario. A business as usual scenario that in the end, would assume that, all the stuff, the interesting stuff that's going on keeps on going on. You got a learning curve in renewables, in storage, and a whole bunch of other things. And that's rapid, but it's not quick enough. It's rapid enough to do away with oil producers, and they might not be able to adapt in time, but it's not rapid enough to mitigate climate change. So what you get is a bunch of, negative outcomes, including some of the oil producers having trouble keeping up the domestic social contract. The meta producers, particularly Russia, you might have very different ways in which countries and regions start thinking about energy policy. Europe is assumed in this scenario to go for partnerships. The US stays a little bit on the sidelines. And because you don't have that global consensus, and because you have a rather scattered environment, some of the regions in the non-OECD world might not be able to benefit from the learning curves that you still have. As a result of all of that, fossil fuels stay in the system, peak, go down a little bit, renewables go up, but not necessarily where you need to have them for a 1.5 or 2 degree scenario. Now, in the end, that means a bunch of imbalances being reinforced, particularly when it comes to global north-south relations. A scenario that for most part resembles the pathway that we're on at the moment. Now, what does all of this mean? Let me just conclude with 2 slides here. One is essentially we try to kind of think about the implications, for all of this for a bunch of criteria. The most important bit that I just want to point your attention to is the international political architecture, because depending on the scenario you're in, you either get anarchy or a zero-sum mentality, a dog-eat-dog world, that's the dirty nationalism one, or you get a multilateralist framework, that's the best of all worlds, and a bunch of things in between. But the point is, essentially out of all of those scenarios, only one is the one that you would really find desirable in terms of where the world goes and how we behave as a global society. And obviously it has foreign policy implications, and that has been our initial task and the initial goal of all of what we came up with here. So let's ask finally maybe what are foreign policy implications of all of this, or the global policy implications. And I guess the long and short of it is, I think it's such a nice phrase, so I have to have to read it. A zero carbon world does not do away with zero-sum games; it just produces different ones. So if the race today is about what's in the ground and how you get it out, the race in the future might be about technology, financial flows, and stuff, including some of the extractive business, including rare earth materials. One of the things that came out of the scenarios is also that a win-win is possible, but not the only plausible outcome. So we need to prepare for that. And an important bit is also that the pace of change matters a lot for the degree of conflict that you might see. If you're too quick and if you're not compensating, that actually means that some of the incumbents might face a hard time, and that might spell conflict because of just for the sake of the argument, the MENA region seeing conflict, that means spillover effects to global markets, to other regions, and so on and so forth. And so in the end, we try to kind of condense all of this in a couple of recommendations, and I think the most important bit of it is that we need to acknowledge that abating carbon is not only about winners, it might be about losers. There is a very important bit of preparing for all of this is to think not only about the end result, the end game, where you want to be, but also how you get there. So it's about the pathways and how you manage them. So it's a lot about transition management and thinking about transitions management, not only in terms of your domestic energy systems, but also in terms of global policy. And then the one thought that came out of all of this in the end also is, why pretend we don't know transition? We know transition. We have been through transitions. We have been through massive energy transitions in the past. We have seen transitions from plant to market. We have seen transitions from authoritarian regimes to democracy, and we can draw lessons from these transitions. They're not necessarily all unique. So doing that might help us in addressing some of the concerns and some of the challenges that we identified in the scenarios. And with that, I think I just conclude. Thank you very much.
So I think Sarah and I are going to keep our remarks very short so that we can still interact with you here in the audience. We've had a lot of information to absorb. I just I think I'm going to serve, and we say in the academic community, as a discussant. So you've had a lot of information to absorb. What do I think about that information instead of starting with sort of a new subject? And I think that when we look at these scenarios, and I think our opening presenters have done a good job sort of showing you the wedges of what one would conceptualize, what contribution can come from renewables and what contribution can come from changing our car technology and so forth. I guess I would tell you from some of the work that I've done traveling around Silicon Valley and other places and looking at how people are looking at sustainability from a very different lens of this sort of infrastructure solutions, is to think about the fact that we're moving into an age where today 50% of the world's population live in cities. A lot of those cities are coastal, so we know that that's going to provide some challenges from a changing climate. We also know that by 2050, in the time frame of these forecasts, 80% of the population, according to the UN, is going to be urbanized and living in megacities. We can see today already some of those big megacities in China, in India, and other places in Africa. We're talking about cities of 30 to 50 million people. And if you think about cities to 30 to 50 million people, and we're all worried about what's going to happen with batteries and what's going to happen with electric cars, if you think about the worst day of traffic in Denver, which is a relatively small city, then you can imagine that in a city like Mumbai or Beijing, people are not going to be able to organize their lives around an automobile, and they're not going to be able to have personal automobiles. And if you then look out into the technology future and think about automation, Maybe none of us are going to be driving at all because whatever vehicles we're going to be using, they're going to be on demand and they're not going to have a driver in them. And they're going to be organized around an algorithm, kind of the way, think of like a combination between your Waze program and your current Uber system. So we're really going to be approaching things in a different way. Maybe cities are going to provide access to services in a way that doesn't require you to move from one part of a city to another. And so whenever I hear these scenarios for rapid decarbonization, I always feel very pessimistic. But I'm really a big believer in human ingenuity. And so I really do think that when we focus on these issues, we have to really think creatively. And I just finished with one last point. We're going to have to think creatively, and you can see this in this country, in the United States alone, because as we have more severe weather, the current infrastructure we have I lived in Northern California for 5 years, had to put my cards on the table, and then I lived 25 years before that in Houston. So I've been a major evacuee. But I think having had that experience of having to evacuate for different kinds of disasters, I think we can understand that as attached as we are to our current lifestyle and current infrastructure, we're going to actually need to adjust and be creative and come up with better solutions for mobility and for electricity and heat. Because some of the solutions we're currently using are not going to be maintainable in the kind of housing and urban settings that we're going to live in.
Good. All right. Well, thanks very much to Morgan and to everyone for hosting this discussion today. I am a big fan of scenarios. I use them a lot to sort of shape our thinking on the energy program that I run. But I'm going to depart from that just a little bit because I think that while I think all of the sort of thought-provoking things that were put on the table, both in the geopolitical scenarios and the energy decarbonization scenarios, are really helpful, I find we're in this like really unique period of time where there's enough change right now to make people's day-to-day sort of decisions about their strategic options today relative to the next 5 to 10 years daunting enough, and the next 20 to 30 to 40 years really, really hard to grapple with. And so I've spent a lot of time, I work in a think tank where I'm one of 30 programs, right? So I think about energy all the time, but the other people I work with think about a whole bunch of different dimensions about what's happening in the international landscape and broadly this term geopolitics. And so what I find is there's so much churn right now in the geopolitical environment that it's really helpful for framing my thinking about what's happening in the energy sector if I start with sectors other than the energy sector, right? So for example, and I know this is an issue Amy thinks a lot about, but like in the sort of like big data tech side of things, like there's an open question in my mind as to whether or not the energy system is going to be fundamentally overhauled by the fact that energy will become almost free to be able to produce, and the infrastructure will be costly, and the information about what you use will have a value. Like that's another completely different scenario that we don't really think about, but it is certainly part of what my colleagues who are doing sort of the future of information technology and the fourth industrial revolution think about the potential for like really upending our energy system in a way that we're not thinking about. We think about integrating some of that stuff into our low carbon solutions, but there's a real chance that that could be sort of a big sort of game changer in the energy space. The other one is that, fundamentally geopolitics right now are changing. And so we have Henry Kissinger is a board member at CSIS, and he's written a lot extensively about how the rise of China has given this period of time where countries are actively renegotiating their positions on the world stage, right? And this is a realpolitik kind of environment where actually energy gets pulled into that struggle as opposed to as the defining feature of that struggle. It can also be a defining feature of that struggle when you think about, the race for decarbonization, but it can also just be like how is China investing in a whole bunch of countries around the world, and are they winning over soft power influence, and what does the U.S. want to do about that, right? Or how are we thinking about in influencing sort of the future of geopolitics in Africa, and is the United States competing with other countries effectively to do that? So in my world, those are the kinds of things that people are thinking about on a geopolitical lens. To a deeper level, there's also this question about the late Dr. Zbigniew Brzezinski was a board member at CSIS, and he wrote about the mass democratization of information and global awareness, right? So this idea that like people all over the world know much more about the world around them, and they have demands and they have thoughts about their futures, and we have to be able to incorporate that into democratic and non-democratic processes. Again, these are things that are not the energy sector, but they are geopolitics. And so I think when you take into consideration that really dynamic technological and geopolitical environment, and then you also overlay it with all the things happening in the energy sector, which are truly, truly transformative. It's just hard to transform a system as big as the energy system very quickly. It leads you to sort of having to figure out, whether or not even our most imaginative scenarios are capable of having us figure out what we think this future might look like. And so I basically have the 3 C's of the energy transition that I tend to think will help me sort of like align defining features. And the first one is competition, right? So an environment where you have more technological choices and more resources is going to be one that is fundamentally more competitive. And I know we always thought that an energy scarcity framework was particularly competitive. I think an energy abundance and optionality framework is going to be way more competitive. And so when I talk with companies, even incumbent companies in the energy system, what they're concerned about is whether or not they're going to be able to compete. If you're in the oil and gas industry, you've got to go work to figure out who your customers are now in a way you just didn't have to before. And so I think that that's really important. The second one is consumers, right? Consumers, the consumer base has changed, and I think this is brought up in a lot of the scenarios. It's new people in new countries that are going to be the source of growth. And their trajectory for growth may not be the same one that we followed. And I don't just mean how energy intensive it'll be, but I talk to a lot of countries around the world who want to follow the China model, right? The idea that you don't just want the lowest cost energy supply to fuel your growth, but you want it to help you build an industrial policy. You want it to help you do something that's different that will help you compete. And that's a different kind of consumer leverage that we don't really, think about. And then there's sort of like the consumer element, which is like the prosumer, which I think you're probably all more familiar with. And then the final one is crises. And I don't mean this in an alarm raising kind of way, but there's just a series of things for which we are not prepared to deal. The first is cybersecurity. If you look at sort of like the history of warfare, we're going to have a massive cybersecurity issue before we come up with like real rules that govern what's inbounds and out of bounds in terms of cybersecurity. So I anticipate there'll be some degree of cyber crises. As Amy just mentioned, I think there's going to be climate crises, right? So climate impacts, we are deeply unprepared to deal with those. We're too late to avoid them. And so we're going to have a lot of climate-related crises as well. And the third one I spent a lot of time thinking about is sanctions and trade-related ones. Even at today's level of sanctions and economic statecraft and warfare that we're seeing, we're already sort of, doing harm to this globally interconnected energy system that we talk about. And I think it's going to precipitate in a number of trade-related crises as well. So I don't know what the future is going to look like. I don't know what 2050 is going to look like, but I do have a sense that those 3 realms might be some of the themes that I'm going to use to think about geopolitics and the energy sector for the next couple decades. Thanks.
Thank you.
So now you can expand your brains, and we've gone well beyond the energy sector. We're having technical difficulties ad nauseum. So you're going to have to speak up, I guess. So we'll start a Q&A session. And again, tell us your name and your affiliation, or if you're a student. A lot of the students have to go back to class. But we have about 15 minutes for Q&A, and you have an extraordinary group of people up there. So please let us know. Is that mic working? No. Yes, sir.
Hi, good afternoon. My name's Mike Young. I'm an alumnus from the School of Mines. Graduated back in the 80s. I used to work for the State Department. But the question I have for you guys, especially Amy, you said that we're just going to have to adapt to some of these crises and climate change, things like that. have you thought about, or and this is a question for any of you, how resiliency, is going to play a role in how people are just going to adapt, as opposed to just doing it, and how policy-wise or otherwise should we focus on getting populations to be more resilient, either through policy methods or other methods?
So let me just say that there is a role, obviously, for government, and there is a role for technology innovation. And some of the technologies that the previous panel talked about coming as solutions, they can be married together with, for 3 decades, people have been coming to the School of Mines and talking about transition scenarios and solutions. But some of these solutions have in them inherently things that will actually also mitigate the climate. So if you think about coastal erosion and severe storms, I can tell you from living in Houston, there's a group of scientists in Texas that work on if we restore wetlands, if we restore mangroves, if we restore forestry, how much solution can that bring, not only by creating a sink, but also by protecting human life and property. And when we think about the electricity system, it's always been the case that scale economies mean that we want to have a big centralized plant and we want to lay wires from that plant and so forth. But we're going to have to think about how we do things differently, and that's going to vary by geography. In some geographies, the panel talked about sort of the justice of climate change, right? So there are going to be places where people are already not at the proper level of economic development, and maybe in some places climate change is going to make that much worse. But maybe some of these new technologies that we're looking at are going to be better suited to deliver energy solutions to people in a small-scale way. And in a flexible way. Morgan and I wrote an article a few months ago where we looked at, and you think about Puerto Rico, Tesla Energy, so not the car part of the company, but the battery storage and solar panel division of the company, was able to go to Puerto Rico, and in 3 days, once specialists could come and clear the sort of wires that were dangerous, they were able to install solar panels and a battery system for hospitals in Puerto Rico in 3 days, right? So if you think about refugees, and you think about movements of population, which we keep seeing over and over again on the news, and you think about that technology, and people are living in tents, and you think about how difficult that's going to be at higher temperatures. Well, if you could provide a fan or some kind of temperature control running off of solar and batteries that can be installed in 3 days and decommissioned in 3 days if you come up with a more permanent solution. These are things that need to be looked at. And in our national dialogue, when we pit technologies against each other, right? So we say wind is bad for natural gas, or natural gas is bad for wind. We're not going in the right direction, because what we really should be thinking about is the Congress going to pass an infrastructure bill, and how do we marry together what we need to do to have our infrastructure be more sustainable with what are the future technology per location that would deliver the best resilience and service to people. And I feel like we almost need a new market for what I call natural capital. That's sort of a buzzword in the environmental community, but let me introduce the idea to you that we just don't want to have businesses believe that their use of water is a priority, and so they're going to use water without thinking about what stewardship is, or even arable soil. We're going to get to a point, the United States has this amazing opportunity to not only protect our own population, but to do service in the world. because we have these amazing natural resources, whether it's arid soil, whether it's forestry, our ability to raise, livestock, our ability to have clean water, agriculture. There are things that we're still going to be able to do as a country, that there are going to be other countries that are not going to be able to do that. And if we were to squander it, because there's some business profit that could be made by deteriorating that natural capital to the point where it's not available to our service anymore. I mean, people talk about the rise of China and, asymmetric warfare and drones and cyber and all these things. But the bottom line is the United States is bestowed with incredible natural resources. And if we steward them, 50 years from now or 30 years from now, when your children and their children are still in that stewardship pathway, the United States could still be the most dominant country. I don't care how much technology the Chinese think they're going to throw at everything, because we are going to have the natural resources that are going to be required to sustain, sort of a positive, resilient life. And we need to help markets develop a system where we place a value on arable soil, a value on the use of water. I mean, I don't have to tell people from Denver that you cannot produce electricity without water. Thermal plants require water, nuclear plants require water. We're not doing oil and gas production without water. And so, again, we need market solutions that incent businesses. And I was really pleased to hear the panel say today that it's important for corporations to take the lead even when government is unable to take the lead. Because ultimately, corporations can create these credit markets where they trade and add value to the natural resources that they need to do their businesses and that we need to live. And I think that when we talk resilience, that's sort of the framework around which we need to think about it, right? Which is sort of aligning our future infrastructure with these kinds of values that we have to promote to make sure that we, the United States, are a sustained economy, a sustained geography.
I was just going to say on the, very quickly on the sort of like resilience adaptation thing, I think we spent a lot less time providing frameworks for people to think about how to strategize around that, but there was a recent report, the Global Adaptation Commission, that has done a lot of really great work about various strategies for preparing for more resilient societies, and so they're launching a year of action this year. And so World Resources Institute, another think tank in Washington, was really great in writing the report with the commission. It's a great resource for folks who are trying to get their heads around a framework for thinking about mobilizing around adaptation.
Great. Lucas, you have a mic there, possibly works.
Hi, my name is Lucas. I'm from Petrobras, Brazil, and I'm a master's student here. My question is for Professor Andreas. It's related to what was spoken earlier. What's the influence of poverty and inequality on your scenarios?
Thanks, Lucas. How about I collect one or two more students left? Oh yeah, PK, please. You can speak loudly.
Yeah, my name is PK Sen. I'm a professor of electrical engineering. I just have one small comment and one question for Andreas. The comment I wanted to make for this whole community, we talk about carbon and we talk about renewable energy. To make a really long story short, we did not discuss at all nuclear power in our conversation here. So that's a missing component, big time. When we talk about energy, energy does not mean oil, gas, and coal. And the second point, we talk about, we completely missing the conversation on large-scale hydro in a global sense also. So those are really missing things in our conversation. One other missing thing in the conversation is electricity. We talked about it. The efficiency of electricity production is 33%. So no matter what we do, that's just the facts of life. this is the missing point in our conversation. I just wanted to add my 2 cents worth of input. And the question I have for Andreas is, when you look into the green part of your first chart, did you look into nuclear power? That's supposed to be green. If carbon dioxide is the only thing we talk about here. Okay, did you include that in your conversations or in your analysis? And did you also look into globally large-scale hydro? So that's specifically for you.
Okay, let's go with that. Andreas, you're on the line, I think.
Thanks, great questions. Equality, equity, inequality, justice. I mean, these are tremendously important aspects of what we're talking about here. In the end, it's not the solutions per se that are important and the technology that needs to be there and all the rest of it. It is what it does to people, and whether they feel that the future holds opportunity for them. And that's important because, by sheer numbers, it will simply be a disaster if the emerging economies will have a lifestyle that resembles the lifestyle of most of the developed economies. So a lot will depend on the quality of the services that they get and the quality of life that they have. And technologicals and other solutions need to deliver that. So, but there is another element to this, which is, going a little bit back to numbers. Just in the energy world, that's the world I know best. And so I stick to that. I mean, I'm not telling you news. I mean, there is, more than 1 billion people lack access to clean energy services. This is a number that's probably going to rise as the population grows globally. And it is not, so the promise of the energy transition is to deliver on that end as well, in addition to transition us into a sustainable low-carbon future. This is going to be a tremendous challenge because, if you just look at the numbers and just going back to some of the scenarios that we built here, just in terms of IP, I mean, it's debatable to what extent IP is really an issue in energy, but just in terms of IP, the global distribution of patents on low-carbon tech is complete unequal. You have most of the IP sitting with the OECD world and a little bit in China, and that's literally it. So the rest of the world does not hold patents on the kinds of technologies that you need going forward. Now, some of that might be able to you might overcome that by way of licensing and a whole bunch of other things. But a lot is not only about the IP itself, it's about the knowledge and the capacity to use that knowledge that comes with it. And this is exactly where inequality is a thing that is, where we are at risk of persisting a pattern that exists already. Because there is reason to assume that it's not only about the technology traveling to other places where it is needed. It is about the technology being absorbed properly into local environments. And that's exactly where the challenge is. We're not tackling this. And the energy transition, we need to get that part right of the energy transition. Otherwise, we'll fail on the equity front. If you look beyond patents, you find similar patterns in financial flows. I mean, the good news is that most renewable energy investment is now outside the OECD world. That looked a little bit different a couple of years back still. Now the majority of the investment is outside the OECD. But if you unpack that, it essentially is 3 countries that get it all. It's China, India, and Brazil. And just a marginal share of renewable energy investment is outside those big 3 countries. Now, in terms of climate change, that's great news, because you want to get the money where most of the population is, most of the economic growth is, and where most of the emissions are. And that's exactly why it's good news to have most of the renewable energy investment being allocated in those 3 countries. But from an equity point of view, it's a disaster, because you leave out Africa, you leave out parts of Southeast Asia, you leave out parts of Latin America, and so in effect, what you get is a world that might, where some parts might go happily green, and some others might not be able to do that. And so I guess one of the normative implications of all of this is that we really need to think very carefully about, not only technological solutions, but what we do with them and what they can do to people outside the areas where we see most of the investment at the moment. And maybe a final thought. I mean, the energy transition is. Sorry, I'm going for way too long here. But the energy transition is supposed to deliver all these co-benefits, right? I mean, it's not only about mitigating climate change. It's about delivering things to people that matter: health, literacy rates, because people can if they have access to energy services, they can study at home during the night. There's a whole bunch of other things that there's a whole gender component to the energy transition, which is absolutely important. In addition to countries not being able to possibly transition into a low-carbon environment, all of that might not be delivered. And that's part of the justice discussion that we need to have, I think. And we're not having that discussion at the moment. Just very quickly on the scenarios. I'm trying to find an easy way out here. So the point is, we did not put in numbers behind the scenarios. We did not say, look, this scenario X means, 25% share of coal or whatsoever. So we did not say whether nuclear is in it or out of it. What we said is the definition is low carbon tech. And I leave it open of what that means. We didn't have an agreement on this in the group.
But let me make a comment on nuclear to move on, because for nuclear, it's very important to make this comment. There's a huge potential. And obviously at scale, at a higher scale, then maybe it's easier to do than renewables. Here's the problem. I don't know if you watched the HBO movie on Chernobyl. And the question is, in which settings do we have government institutions that can deliver nuclear power safely? And if you look at what the consequences might have been for Chernobyl, which luckily we didn't have the worst case scenario, but the prospect of what the worst case scenario might have been, and the fact that the Soviet Union was going to allow that to happen and then not convey those risks to the rest of Europe, when you watch that show, is quite frightening. And if you think about corruption and inefficiencies in places like China, and other countries that are really pushing forward with nuclear power, I do have some concerns, not because of its ability to really deliver the kind of solutions that we need, but because of the limitation of humans in certain societies or certain political institutions to deliver it safely.
Thanks. And Sarah, how about the last word on anything?
On anything? Wow, that's quite an invitation.
The just transition part you're working on?
Yeah, I do think, listen, I think this gets to this broader dialogue here, which is, I'm worried that we are putting on energy policy a lot of societal transformation stuff that is related to some really important just transition concepts, right? So we did a project in the U.S. called Energy in America, looking at what different communities want out of their energy system. And while I think, making sure that frontline communities are protected from climate change and making sure that there's environmental justice for, disenfranchised communities who disproportionately get the negative environmental impacts of all the energy system that we have, all these things, if we want to make sure there's a just transition for workers who are disenfranchised by the energy transition, all that stuff, we have to face two things. One, we're terrible at all those things, okay? We have systemically neglected them. So we will have to find systemic solutions for them. And some of those things are not priced into these transitions. These transitions don't actually think about any of that. And secondly, when it comes to making communities whose economies are changing quickly whole, you can't do that just through energy policy. You need a bunch of other kinds of policies. And so I do think it's really important for us to recognize that, yes, there are, as Andre said, I completely agree, there are lots of complementary benefits that come with a clean energy society, But there's a bunch of other things that we need to deal with that are put on the expectations, particularly in concepts like the Green New Deal, that are fundamentally going to be delivered in a much more sort of economically efficient and democratically responsive way if we don't just think it's like the energy sector that's going to deliver them, right? So I think that that's a whole other part of this conversation that is important to keep in mind.
That's great. Thank you all so much.
Hello, my name is Terrence Chatchula. I'm entering my 19th year of volunteering out here at the School of Mines, but welcome and thank you for coming and thank you for all the visitors to the School of Mines. Seems like all three presentations were based on the premise that climate change is caused by CO2 concentrations, which I call CO2 climate change theory. The truth and the reality is there's no experimental data that supports the tie between carbon dioxide concentrations in the atmosphere and global temperatures, unless y'all can reference me to some experimental data. I've contacted a number of people and have not found that yet.
Question, please.
I'm sorry, what?
Question, please.
Okay. I would urge you to take a leadership and do an experiment. My back of the envelope calculations show it can be done for about $3.7 billion. The sad thing about this premise is that it's going to keep more people in poverty for a longer period of time.
Okay,
I guess my question is, do you have any experimental data that supports that theory?
Hi, I'm Robin Swank. I'm an independent here in Denver, 20-year petroleum geologist. I like the graph that you showed, Mr. British Petroleum, about the oil going into 2050. Do you have a corresponding one for natural gas, and what might you anticipate that looking like? What investments might be needed to meet that curve?
Perfect. Let's capture one or two more questions. How about some students? You get credit for it. There you are. He's coming around.
Hi, my name is Gabriel. I'm a graduate student here at the School of Mines. My question is, with rapidly growing demand for energy, even over the next 2 decades, what infrastructure challenges do you anticipate there being, especially with the 50% electricity usage in the energy mix?
Yeah, terrific. How about another? Yeah, one more student there.
Hi, my name is Wanola. I'm a graduate student here at School of Mines, Advanced Energy Systems. One question would be for the oil and gas industry, what recommendations would you say as regards clean energy incorporation in oil and gas?
Great. So let's stop there, and the panel, you can take that. Yeah, let's start with IREC and then go down the line and answer the ones you'd like.
Yeah, to the first, does this work? Oh, you can hear me anyway, I guess.
You just have to shift it on, I think.
This little oh, there it is. To the first challenge, I guess what we're saying is that we are not climate scientists. We accept climate science, and we take the IPCC reports as a challenge, and we act upon it, and that's our job in terms of doing that. And climate science will develop over time, and we'll get more knowledge than we have today. On the infrastructure challenge and growth in energy demand, and in particular growth in electricity demand, that's an issue that we should think about. Some of the challenges, both in terms of the necessary minerals that we need for a system which has a lot more requirements for storage. There are studies that show that if Europe is going to deliver on their climate ambitions and decarbonize the electricity sector, we need to increase the size of the overall grid in Europe 7-fold if we want to do it as efficiently as possible. And with existing challenges in terms of being allowed to build wind turbines in the Netherlands or Norway, trunk lines through the Pyrenees and the Alps. So it's an issue that has to be handled. Some of the electricity will be much more distributed than what we're used to, but it probably will need much more large-scale electricity as well. And all these investments will have to take place in a situation or in energy markets where the future regulation is unknown. And what tariff systems will we have in place? What will the price of electricity be when half of the electricity is produced at zero marginal cost? Issues like that. So, and no country has responded. We don't have any regimes in the world that has answered to that type of regulatory challenge. And we see it now as an example in Germany, where last year 140 hours of the year, of the 8,700 hours, we had significantly negative wholesale price of electricity because of the regulation. And you also have the shut-ins in California as an example. So massive regulatory challenges to make this happen. It will happen. Challenges are there to be solved. But it's not a given that it's going to be a smooth ride.
So I'll take the question that you asked on natural gas. So,
otherwise, try this one. Try this one.
okay, so just in terms of natural gas, there's a chart in what I showed, just showing that we moved from about 7 billion tons of oil equivalent of natural gas demand in 2020 to about 10 billion tons. So in terms of the primary energy share, that is a move from about 22% to about 28% in that basic evolving transition scenario. In the scenario where we see a rapid transition and obviously the use of more gas with CCS, then that share doesn't increase as much, but it still increases from 2020 to 2040.
Okay, well, that leaves the third question, last question to me then, which is the clean energy use in oil and gas production. In one of my charts, last one, it should basically show that actually that operational aspect is 15% of the emissions. 85% of the emissions is basically in burning the fossil fuel. So if you want to decarbonize the system, you have to have a solution for all these parts. But focusing on your part of the question, yes, renewable energy is used for oil and gas production. An example, in our own operation in Oman, we use solar heat, for tertiary recovery and processes. We have in the Pernis refinery, we have 20 megawatts of solar panels, just helping to offset a great extent of the electricity used there. We're in wind parks and all this stuff, so all these things are coming in. But like I say, that's only that scope 1 and 2 part of the emissions. But also the targets actually I showed for our company includes scope 3. So when we said we want 50% reduction of our fuels we provide to our customers by 2050, that means we also have to find a solution for the end use, because otherwise it just doesn't work, right? So you have to be realistic in that. But anyway, but indeed, the synergy between renewable and fossil, especially I think the fossil fuel infrastructure, will become more apparent as the renewable industry is going to grow and need to, piggyback on, for instance, the gas infrastructure to spike hydrogen from green electrons into the system. So again, those regions who actually have existing infrastructure, they can piggyback on something existing and therefore hopefully have a lower cost to the end consumer, which helps the infrastructure problem again, Eric, you to discuss. Okay, I'd like to leave it with that.
Okay, let's take 2 more questions. Yeah, students, great. And we have the roaming mic. It's a great opportunity, students. You don't get people like this here every day, so take advantage of it. 2 questions.
Hey, my name is Kemal. I'm working for a government agency in Indonesia. I used to study here. My question is, looking at you guys' scenarios, what is your strategy in terms of explorations and development? Like, are you guys going to explore, still going to the explorations, or are you just keeping the resource production ratios to some years, or something like that, whether you want to test a bit a reserve which is with a quick return or with the capex and stuff? That would be awesome.
Okay, and one more question over here, and then we'll...
My name is Amir, and I'm a Minerals and Energy Economics student at Mines. I want to know what's the outlook for natural gas, say, to 2060. Are we looking at like a bridge fuel to the future before renewables completely take over? Or is natural gas here to stay? If natural gas is here to stay, let's say we assume that, So how do we convince the society to invest in the infrastructure that's needed to get natural gas to places that, say, suppose that are landlocked, right? So the heart of Africa, for example. So that's my question.
Okay, one more. You had one. Yeah, Greg, he's right in front of you. Greg.
Hi there, my name is Tyler Heather, and
Why don't you stand up, Tyler, and speak a little louder?
pretend you're a professor. I'm a alumni here at Colorado School of Mines. Was working as a field engineer, currently transitioning to an energy analyst position. My question is about the use for electric car batteries. It seemed like all your presentations mentioned that there'd be a rapid transition, that all the automobiles would be transitioned into electric batteries. Considering the entire process of getting the minerals to make those batteries, the entire from consumption, is that the environmentally steward way to go about transportation in the future?
Okay, 3 easy questions, gentlemen.
3 great questions.
Yeah.
On the strategy, at least in our case, we will continue to develop new oil and gas. We think we need a lot of investments to continue to follow the demand curve. And we aspire to be the most carbon efficient delivery, the producer of the oil and gas. And at the same time, we're going to go into both renewables and low carbon solutions. And in all kinds of scenarios, there's massive growth in both in renewables and in the need to lower the carbon footprint of any kind of energy. So I guess we're probably in the same boat, but you'll see different choices depending on how the companies are placed along the value chain. And my 2 colleagues next to me represent the companies that have much more downstream activities than we do, as an example. Natural gas is here to stay, we think, and it's also a potential source for future hydrogen production as well, if we need to get the emissions even further down. So in our case, we have a 20% reduction in gas demand to 2050 in a scenario where you actually reach 1.7, 1.8 degree warming. So natural gas is here to stay. And then the challenge for gas is that it's more capital intensive and it's less profitable than oil. It has much longer lifetimes before it becomes cash flow positive. So that's a market. It's a market issue. It's the price will have to go up if we're going to get sufficient amounts of investments. I'll leave the electric batteries, but I'll leave the word to the others in the interest of time. But it's a massive challenge.
So just to take those 3 main questions. So first, likewise, we see gas as being a very critical part of the energy system. We right now have a portfolio that is constituted in roughly 60% for natural gas going out to 2025, excluding Rosneft. We also instituted a reduce, improve, create transition framework about a year ago. So that includes GHG emissions objectives and as well just reducing increasing the amount of allocation of capital into new energies. So in terms of, are we still exploring? Yes, we are. Increasingly, that will be weighted towards natural gas, and increasingly that extra capital that we have left over after every year increasingly is being put into our new energies division. So in terms of the other questions, you asked about the role of gas in 2060. Our forecasts right now only go out to 2040, but next year we'll go to 2050. So I'll let Wim say what he thinks at that point. I do think that from our perspective, we see massive potential in blue hydrogen. So hydrogen from natural gas, or the blending of additional amounts of hydrogen in currently used natural gas infrastructure. And so we see that as one possibility. There's also, in scenarios that we've run, in the last year's scenarios, increasing amounts of, we need to see gas with CCS, but obviously the economic viability of that is still in play, and we need to see improvements in that in order to see a greater penetration. But I do think that as we look out into the next 4 or 5 years, natural gas has a real problem in terms of ensuring that its climate benefits remain. And I think that it's important to understand that if the industry doesn't take significant steps to ensure that is the case, that methane emissions are reduced, not just overall in terms of intensity, but actually the overall amount of methane emissions, then we're going to have a real problem in ensuring that the public in this country sees natural gas as providing the climate benefits that it can provide in terms of its ability to penetrate into areas that are primarily coal fire, where we have much more coal-fired generation. And then in terms of electric batteries, chemistries will evolve. And so while we have this concentration of cobalt in only one or two key countries that are not, Democratic Republic of Congo, not democratic nor a republic, then that is a problem now. But based on our modeling, going out into the 2040 and 2050 timeframe, we see those chemistries continuing to evolve, where cobalt is less of the composition of the battery. And I know Morgan has spent a significant amount of time on that, so maybe that's something that he'll talk about as well. So.
Okay, Payne, you have the last word.
Oh, hi. Well, there's most have said actually, so I don't need to go too much detail. But just say on the gas question. So even in the Sky scenario, by the late 2040s, the world still consumes as much gas as it does today. And in the meantime, we have to have up the ante a little bit, because in our scenario, gas is the low-hanging fruit to replace the coal investment. So coal is flat, peaking. It already peaked in 2014, and it stays flat in our scenario. So gas have to take over in the medium term. So very clearly that it's at least a bridging fuel, but ultimately, and you see that in our scenarios post-2040, it really is a rapid decline, a pretty rapid decline. So it's not exempt in that sense for the energy transition, but actually that is if you look at the energy consumption, if you look at actually the installed capacity, that is not going to have such a rapid decline, because in the end, if you have that gas-fired backbone of your electricity system, you're probably going to keep it as your insurance policy for those days, the wind is not blowing or the sun is not sufficient. So this is an incredible opportunity for integrated energy planning, right, for the new system, is that when you have these systems, keep it, maintain it, because that's your insurance policy for intermittency. And of course, this is all about, decades to go. And sometimes people look at the end point and say, oh, we don't need it then, so why bother now? But to get to that end point, you need still a transition, still need a journey. And that journey has certain steps. The innovation doesn't go in one giant step forward. We do that incrementally. And so even if you think it is not a lasting fuel, still you need to go through these these two cycles with natural gas to make it happen. Very good examples for shipping. People say, should you have LNG in shipping? Yes, it's 25% less CO2 emissions. It's not the end solution, is it? True, but it's something you can do today. And 25% is 25% reduction. So all these little things, they add all the time. On the batteries, I leave that there. On ISC strategy, you will see it evolving. When you look at our scenarios, there is a place for niche fossil hydrocarbon companies, right? Because if you believe that society is going to decarbonize, then small companies can still produce that stuff and looking after their own emissions, and somehow the system will cover that. But if you're an IOC, my CEO has been on the Bloomberg interview and says, well, should we still see ourselves as big oil? I like to see myself like big energy in the future, actually, and now. And that's a mindset, that's his vision, right? Very clear. He has a very clear view of how this pathway is going to change. But bearing in mind that the coming, say, decades, we still need even more, in the meantime, fossil fuels and then going down. That, of course, also the company needs a backbone of profitability. Because if you don't make money, you're not part of that transition anyway, because you have no money to invest in the new system. And we're very clear in that, also to our shareholders. So at the moment we have 1-2 billion a year. We've ramped up our new energies from 60 people 2 years ago to 800 people now. So it's only a kind of institutional capacity, how fast can you invest, but that's going to increase significantly over time. And it's a very clear vision where we want to go. And one of our executive directors have, again, in the public domain, saying that his ambition was to have 67 gigawatts of wind power, of renewable power. I quite like his number 67, but it's about, I think, like for like on the end use, 100 gigawatt is about 1 million barrels equivalent. So that seems about in line with our carbon reduction targets. So he has an enormous challenge to actually deliver there. Thank you.
Thank you all.